1 is mainly introduction, and we are going to be looking at anatomy. So anatomy part 1 is looking at mainly the body and the structure. Part 2 looks at the physiology on how things work. All right. So again, when we look at them, we're going to be looking at the different branches in this chapter of healthcare. All right. So when you look at physicians, they have what? Specialties. You got a cardiologist that specializes in the heart. You got an endocrinologist that specializes in the endocrine hormones. Exactly. All right. You have a neurologist, brain and the nervous system. All right. Orthopedic, bones and the skeletal muscle system. All right. When you hear the term patho, what do you think about? Patho. Pathology? What do you think about? Diseases. All right. Anytime you have a procedure and they take anything out, where do they send it? To the lab. And when they send it to the lab, you have a what? Pathologist there. All right. To do a what? Specimen of it, a tissue smear of it, because they want to look for what? Abnormalities. All right. They want to look for what? Masses, tumors. If it's malignant, is it what? Benign. All right. So again, we're going to be looking at directional terms. Anybody have taken medical terminology before? Biology 120? It's a good class to take because it goes through terminology. All right. So if you hear the term cardiomegaly, you think about cardio is what? Heart. Megaly is what? Enlarged. So if you see the word cardiomegaly in a chart, that's a patient with a what? Enlarged heart. Right. If you hear the term stenosis, stenosis means to what? Narrow. So cervical stenosis is narrowing of the what? Cervical vertebrae. All right. So that's what they mean by directional terms when we look at medical terms. All right. So again, these are just some of the learning outcomes we're going to be looking at. All right. Anatomy, look at physiology and the subdisciplines of human physiology. All right. So again, when you see the term inspection, palpation, auscultation, and percussion. What is inspection? Inspection. Yeah, to look. You're looking for what? What are you looking for when you're looking? Abnormalities or what? Symmetry. Okay? You want to look at how your what? Patient walks. You know, do they walk with a limp? Do they have a gait anomaly? Do they get up walking with a limp, or it seems like they're in what? Pain. All right. Palpation is to what? Yeah, you touching. All right. And what are you touching for? Okay, that you're looking for what? If it's a mass, if it's a lesion, if it's what? Painful. All right. Auscultation is to what? Listen. All right, don't they listen to your what? Heartbeat. Don't they listen to what? Respiration. All right. And then percussion. What do they do when they percuss? Yeah. You know, have they ever laid a couple of fingers over you and tap it like that? All right, they do that to see if it's dull, you can have a cyst or you can have a what? Mass. So that's why they what? Percuss. All right, especially when they're doing abdomen. All right, when you look at dissection, that means you're cutting something what? Up. All right. When you hear the term gross anatomy, gross means things you can see with your what? Naked eye. All right. So cadavers are people that have donated their bodies to what? Science. So you cut them up and you look at their what? Anatomy. All right. And here I like doing cats because cats and pigs, they're what they call comparative anatomy. Their anatomy is similar to what? Ours. So by dissecting them, you can look at their internal what? Structures. All right. So that's where we get the term comparative anatomy, to look at form and function. All right. medical imaging. When you hear the term medical imaging, what do you think about? Huh? X-rays. All right. And what other things do we do other than just a regular X-ray? What are some other medical imaging? CAT scan, MRIs, all right, PET scans, all right, they can do. So gross anatomy, things you can see with the what? Naked eye. Histology is things we look at with the what? Microscope, all right? And how many people remember from Biology 103, cellular hierarchy, cellular organization? What is it? From the smallest to the largest. What do you look at? You remember? Atom. Then you move on up to molecules, then carbohydrates, then a cell, and a group of cells make up what? Tissues, right? And tissues make up what? Organs. Organs make up what? Organ systems, and an organ system make you and live in what? Organism. All right. So histology is the study of what? Tissues. Cytology is the study of cells. All right. And when they look at ultrastructures, you need a high-powered microscope. And when they say ultrastructures, these are the things that you find inside of a cell. All right. You remember that a cell is surrounded by a cell membrane, all right? What do we find inside of the cell? Nucleus, cytoplasm, vacuoles. Okay, so these are what we call what? Ultrastructures that what? Are located inside of a what? Cell. Either animal cell or plant cell. Perfect. Okay. All right. All right. Neurophysiology is studying the what? Nervous system. Endocrinology is hormones. Pathological, pathophysiology, diseases. All right. Comparative physiology compared to comparative anatomy is that muscles, bones from that standpoint. Heart, lungs. Physiology is what? How it works. How does the renal system work? How does the cardiovascular system work? How does the nervous system work? So we can also look at that when we look at different what? Animals, and we test them for what? Drugs. All right? We introduce cancers into what? Animals. Then we treat them to come up with a way or drug that will help shrink a tumor or help to what? Eradicate it. And until you go through animal trials before you can do what? Human trials, then before you can what? Put it on the market. Make sense? Yes or no? Okay. All right. Hippocrates, Aristotle. These are just some scientists who played an important role in defining medicine and terminology. All right. So Hippocrates, he was a Greek physician, and they call him the father of medicine, all right? So he seeked out natural causes of diseases. You know, back during his era, they thought if you were sick, you had sin, and it was something like a what? Biblical punishment on you for that. And, you know, they used to maybe bleed you, to bleed demons and things out of you. So he came up with what? Diseases and causes for those symptoms, all right? Aristotle, he also looked at the causes, the theology of things, the physiology of things. So he came up with terminology like a physician and physiology and looking at the structural component of a human body. Right. Galen, he looked at gladiators. And what did gladiators do back in that era? They fought, all right? And if you fought, 9 times out of 10, what happened to you? You got hurt or you got what? Killed, all right? So if I'm hurting and bleeding real bad, I ain't going to argue too much with somebody trying to fix me up, right or wrong. And if I'm dead, I can't argue, so then I can dissect you and learn things, all right? So he had like a what? Willing audience to do what he wanted to do. All right? So these are things that you do with what? Teaching. All right? All right. All right. Harvey and Vesalius. All right? They looked at dissections of things. All right? They looked at and developed the first atlas of directional terms of a human body. All right? He came up with experimental physiology. So he looked at the flow of blood in a closed chamber. All right? So he showed how blood circulates through the heart, from the heart to the systems, then back to the heart again. So we looked at what? Oxygenated blood, deoxygenated blood, becoming what? Oxygenated again. Make sense? Yes or no? Okay. Question. Vesalius, he's the one came up with developing and publishing an atlas of anatomy. So he did his own type of what? Dissections. All right, Robert Hooke, he was the one that helped invent the microscope. All right, and if you took biology 103, you used the compound what? Microscope. All right, and if you haven't used one, we'll start tonight with going over the parts of a microscope. So what is the purpose and the usage of a microscope? Yeah, see things you can't see with your eyes. All right. And the parts of a microscope, ocular is the eyepiece that you look through, right? What are the purpose of the different objectives? Yeah, your magnification, all right? How many people know how to calculate total magnification? Alright, so what you do is the eyepiece is always 10x. And the objectives can be 4x, 10x, 40x, or 100. Now for biology 201, 103, 202, we don't use 100x. You use it in micro, because that's oil immersion. That's the only time you're going to use the 100x objective. But to get total magnification, you're going to multiply the eyepiece times whatever objective lens you're using. And that'll give you total magnification. So if the objective is 10, like he said, it'll be 10 times 10, which is a what? 100. Okay? So that's how you calculate total magnification. All right? So you got a light source to illuminate it. You got what are called coarse adjustment knobs and fine adjustment. How many people remember what a coarse adjustment knob does on a microscope? Okay, it moves, well, now the mechanical stage moves it side to side, but the fine adjustment, it brings it into what? Focus without moving the what? The specimen up or down. Okay? All right, Leeuwenhoek, he invented the single lens microscope, all right, and he looked at magnification of fabrics. And tonight in lab, we kind of look at the letter E and fibers that we looked at. They also looked at pond water. And pond water is a thing that if you look at, even though it looks what? Dark or kind of brownish, dirty, you'll be amazed of the microorganisms you can see in pond water that illuminates and have different and bright colors that you wouldn't expect it to be when you just look at the what? Water with the naked eye. So there are a lot of microorganisms that we can see in just pond water or regular water when we look at it with a compound microscope. All right, cell theory. Cell theory is a thing that looks at the fact that all living organisms are composed of a single ancestral cell. So that means we all evolved from a common what? Cell. All right? So all the body functions are interrelated at the cellular level. Okay? And when we look at diseases and things of that nature, if a tissue goes bad and a group of cells make up the what? Tissue. So ultimately we are all made up of what? Trillions of different types of what? Cells. All right? Question. All right, how many people remember the word hypothesis or the scientific method? What's the scientific method? Yeah. Scientific method or hypothesis. Educated guess. All right. So when you think about the scientific method, what encompasses as a scientist developing a scientific method in terms of doing research? Huh? Okay. What else? You trying to prove a point? What else? What are some things you do to get this started? You're both right. What? Okay. What else? What else? What else? Okay. Okay. What else? Okay. What else? Which is an educated guess. That's true. But before you formulate your hypothesis, what else should you do? Okay. Keep going. Research what? Okay then. You got to come up with something to study, right? Don't you have to have a study group? Okay then. So you got to have something to work with in order to do everything. You are all right. But what are we studying? What are the variables are we looking at? Are we doing females? Are we doing males? Are we doing rabbits? What are we studying? All right? Is there an age group we're looking at? Are we limiting our variables? Because the more variables you have, the more things can go what? Exactly. So do you want a lot of variables? When you listen to like UAB, when they're doing these studies and they're recruiting people, don't they set parameters of who they want? Either they want males or females, right? They want them at a certain what? Age group. So they set the parameters who they're going to select and screen to participate in the what? Experiment. So you're right. You want to research what you want to do. Then you come up with a hypothesis, which is a what? Educated guess. Then what else you got to have? What do you think you got to have? Okay, I like that. What else? You okay? But if you got groups, right? Don't you have to have an experimental group and a what? Control. Exactly. Are you giving everybody the same thing? Because you don't know what works and what doesn't work, right? So you got to have a what? Control group, experimental group. You got one group getting a placebo or one form of medicine. You got another group getting a what? Different form of medicine. Make sense? All right. Then you're going to run what? Tests on them. You're going to collect what? Data on them. You're going to what? Analyze that data. Once you analyze the data, you're going to come up with a what? Conclusion. And at the end, your conclusion should support your what? Thank you very much. What if it doesn't support it? Okay, you went wrong. So what do you do to correct that?
You have to do your research all up where you got to do the variables and all that all over it.
Okay. Or you can, or you could, or thank you very much. Change hypothesis. Make sense? All right. All right. So again, when you look at the scientific method, you got to set what? Standards that you're going to use for what? Truth. Right? And based on these, we come up with what? Laws, right? And facts. How many people remember the first law of thermodynamics? First law of thermodynamics. Energy cannot be created or destroyed. It can only change from one form to another. Is that true? Yes or no? Is it true? Yes or no? Huh? It's true? All right, how long has that theory been true? Or that law been true? Since I've been to school in the Stone Ages. Have they ever disproved it? Okay. So long as you can't disprove it, then it's what? Fact. Make sense? And think about it. Energy. When you work out, you lose energy in the form of what? Calories, but you see the calories coming off of you in the form of what? Which is a form of heat. All right? Now, is the energy lost? No. It's just converted from one form to another. If you put water in a boil and boil it, what happens to the water when you boil it? It evaporates in the form of what? Steam, gas. What happens when it cools down? Did you lose it? Change from one form to another. Make sense? Heat speeds stuff up. Coldness do what? All right, so if I put water in the freezer, what happens? It crystallizes. All right? So energy is being what? Stored. It's being what? Conserved. Is being what? Reduced to the point that the molecules slow down so fast that they are moving so slow that they form a crystal lattice and they freeze. Okay? So it changed from what? One form to another. It was not destroyed, was it? Wasn't lost, right? Just went from one form to another. Make sense? All right. Questions? All right. So as we go through this, you want to make observations, generalization, and predictions that you want to do. Reliable observation. You want to be able to repeat and confirm your results. It's not falsified by any credible observation. That means what I said and what I did, you can take it to your lab, run it the same way, and you should come up with the same what? Results if you run everything what? The way it's supposed to be. All right, all truth is what? And what does that mean? Yeah, it can change. How many times they put medication out there and had to recall medication? All right? It worked for 10 years, now it causes what? Problem. All right, but have you all noticed the medications that they advertise now? How many side effects do they tell you about the medicine? Oh, it may cause bleeding. It may cause cancer. It may cause, I mean, what? The side effects worse than the what? Benefits from it. Make sense? All right. How many people pre-nursing? All right. How many people going to nursing school? I heard pre-nursing, but all right. So y'all trying to get a nursing. All right. Anybody in nursing now? All right. How many people pre-med? Pre-pharmacy, pre-dentistry, pre-pharmacy, pre-med? All right. All right. All right. So all y'all be taking what? Some form of nutrition, some form of pharmacology. All right. All right. So hypothesis is a what? Educated guess. So you want to come up with a formula to do what? Test that hypothesis. All right. And it continues to work provided you cannot prove it to be what? Wrong. And once you prove it wrong, then that means what? It's no longer considered to be what? True and factual. Okay? So now you got to go back to the drawing board and come up and create something totally what? Different. All right. So when you're doing your experimental design, the number of subjects, you're going to do 5 people, 10 people from that standpoint. A control group, an experimental group. When you hear the word psychosomatic effects, what do you think that means? Psychosomatic effects. Okay, exactly. Okay. So if I give you some medication, and I tell you that this is a new medicine on the market, and it's going to definitely make you feel better. What am I doing? Yeah, I'm setting you up to put you in a positive state of mind that this medicine is going to be what? Beneficial and to what? Help you. It's different if I come in there and say, well, I got good news and bad news. All right? The good news is we know what's wrong with you. The bad news is you got 6 months to be here. All right? So if I tell you got 6 months, do you want to hear anything else I got to say? You want to hear any kind of treatment I got to tell you? All right, you've gone into a state of what? Shock, denial, depression. All right? So now you just leave me alone. Ain't nothing you can do going to make me feel any better because I'm finna what? Die. All right? So placebo or psychosomatic effects is a way to make you what? Feel better. And they say laughter is better for you than what? Depression. Because when you get sad and depressed, it facilitates what? Sickness. All right? Have you seen a person depressed? A lot of times they got a lot of what? Ailments. All right? As compared to a what? Happy, go-lucky person that just don't let nothing bother them. They have better what? Blood pressures and all like that. Stress kills you. All right? It runs your blood pressure up, can cause arteriosclerotic disease, can cause heart disease. Okay? All right. Experimental bias. What do you think they mean by experimental bias of the double-blind study? I like that. All right. So what that means is, let's say both of you all, you scientist A, you scientist B. All right. I'm over both of you all. But only I know who I'm giving the placebo to and the actual drug. Therefore, you cannot influence your study group because you don't know if you got the drug or. So I'm cutting down on what? Bias. So you cannot influence the outcome of your what? Experimental design. All right. And then you got to do statistical testing. All right. So you look at the probability of it being effective. All right. You know, like I say, well, look, Down syndrome. If you're over 40, 1 out of 1,000 births, you may have a child with what? Down. And they just do that with the probability of how many kids that have been born over a certain period of time from mothers over 40 years of age. Then they come up with that what? Probability. All right. Question. All right, peer review. All right, how many people work a job? All right, how many people get evaluated on their job? All right, who evaluates you? Your boss. Okay. All right, so when you all go out and become a registered nurse or a MD, all right, so the MD is not going to what? Who's going to evaluate you? No. For your job, who would evaluate you? Another nurse. That's what they mean by what? Peer review. Your peers evaluate you. I don't want anybody over me or under me. I want my peer. So doctors evaluate what? Doctors. The nurse don't evaluate you, but that's what they mean by what? Peer review. Okay? So your peers that will interview you. All right? So it assures what? Objectivity, being honest, and what? Quality of what? Assurance. All right? Make sense? Yes or no? All right. Facts, laws, and theories. A fact, information that can be independently what? So that means if you do something and we send it over here, she should be able to run the test and come up with the same information. Generalization about the way matter and energy what? Behave. What we just talked about. All right. Theory. Set of statements derived from facts, laws, and a confirmed what? Hypothesis. All right. So a theory is that I have retested it, I have proven it, and confirmed that this hypothesis is supported by the what? Conclusion and the data that I what? Obtain. All right. Make sense? All right. So it all goes what? Together. All right. Who remembers Charles Darwin? Anybody? Who's Charles Darwin? All right. What is evolution? Evolution. Yeah. How things what? Evolve. All right. What about natural selection or survival of the fittest? What do you think about? Natural selection. What do you think about? And what determines that? Huh? Okay, what else? Huh? Okay. Huh? Okay. Okay. Adapt. All right. What they say, the strongest survive. Sometimes that's true, but sometimes the smartest survive. All right. But it's the thing is being able to what? Adapt to your environment in order to what? Sustain yourself. Make sense? Okay. So natural selection is you're all right. All right. So you do what you need to do in order to survive day to day. All right. I like the Animal Channel and Discovery. All right. And when you look at things, which are the animals that get to reproduce all the time? The strongest male, right? The alpha male. Or with some packs, it's the alpha what? Female. But they get to eat what? First. Yeah. I mean, in lions, who hunts? It's the male or the female. All right, then who eat first? All right, what happens when male cubs are born? He get rid of them. He don't want no competition. Right? And then what happens when a new male comes into your territory? You're going to try to fight the one that's there, and whoever survives, the other one has to what? Leave, or he what? Gets killed, but the strongest what? Survive. So they get to what? Reproduce. They get to eat first. They always get the what? Cream of the cream. Right? Make sense? Same thing with people. Rich get richer, poor get poor, right? Right. The big people step on the little people, right? All right, evolution, change, all right? How organisms, what? Evolve. How many people had an infection of some type and they had to take antibiotics? Anybody? All right. When they give you antibiotics, what do they normally tell you to do? Take all of them until you complete the course. Why? Yeah, because if, you know how we creatures of habit. Once we start feeling better, we do what? All right. Then we start feeling bad, we'll do what? All right. Does it work all the time? Why? Well, what happens is that just like we reproduce, bacteria reproduce. They make little baby bacteria cells. So if a mother has developed a resistance to the antibiotic, don't she transfer that on to her baby bacteria? So now that new strand of bacteria is resistant to the antibiotic that you quit taking. Make sense? All right. All right. How many people remembers about DNA replication? Anybody remember about DNA? You know, DNA is the hereditary information, right? And our body makes a copy of DNA onto messenger RNA. Okay. How many people heard of HIV? Everybody? All right. HIV is a very intelligent virus. You know? Because what HIV does is it gets in your body. Now, a virus is an organism that cannot survive on its own. It's a moocher. It likes to feed off of your stuff. You ever had a cousin, a relative, a friend? I ain't never gotten it. I always bum. Man, let me have a cigarette. Man, let me have $1. Man, let me have 50 cents. I'm going to give it back. I'm going to give it back. They'll never give it back. All right. So what HIV does is it invades your body, comes in through the back door. But what it does is it gets incorporated into your cell and your DNA. All right, and it takes your messenger RNA. And what it does is that since it cannot manufacture your original DNA strand, it takes your RNA, it reads it backwards, and develops a new DNA strand. And then once it does that, it begins to manufacture HIV from your DNA that it read backwards and got the blueprint to it. Then it just starts growing inside your body, and you don't even know it's there. And it can lay dormant 5 years, 10 years, 15 years, 20 years. Then it say, now I'm finna convert from HIV to AIDS. All right? So organisms are very what? Smart. All right? So they know how to use your cells to make them work what? Against you. Make sense? So that's why we come up with resistance. All right? Natural selection. Promote reproductive success for some individuals more than what? Others. Predator and prey. Predators, they hunt what? Prey. Do predators hunt the biggest and the strongest or the weakest and the sickest? Yeah, if I can get you without a lot of work and expenditure of energy, hey, I'm fine. All right? And if I'm going after big prey, I'm going to have some help to what? Bring it down. All right? Adaptation. All right? During the summer is real greenery. All right? So animals, they camouflage themselves. Now it's getting wintertime, snakes. You're going to see what? Boars, rattlers, because they mix in with the what? Logs, the brown leaves on the ground. So they hide, and you walk up on them, next thing you know, you bit or something like that. Make sense? So that gives them a what? Advantage to what? Survive. All right. Chimpanzees is very similar to our what? DNA. So it's only 1.6% difference in our DNA structure and theirs. Right? So what we do is we try to find specimens that we can study. All right? Now the only thing is that Since they are so much similar to us from a genetic standpoint, they say it's unethical a lot to do what? Tests on them, right? But also you want to find things that you can do tests on that is cost what? Effective. Okay? Because if I got to spend $100,000 on one specimen as compared to getting smaller ones where I can get enough to run my whole entire experiment, I'm going to go with the cheapest specimen that will yield me the same what? Results. All right, primates, again, monkeys, apes. All right, arboreal are things that live in the what? Trees. All right. Some animals are what? They have stereoscopic vision. They got good depth of perception. Some animals hunt good at night. Other ones do not. All right. We have what is called a what? Opposable what? Thumb. We can grab our stuff right. We can grip it. Other animals, they cannot, can they? So they just try to hang on. And most animals, cats, tigers, how do they bring their prey down? Yeah, when they get them, but what do they normally grab them to bring them down? All right. And why do you think they grab them here? You cut off the oxygen. And if you don't get oxygen to the brain, what happens? You collapse. Okay? All right. All right. Bipedalism is standing upright and what? Walking. Bipedalism is walking what? On two legs. We have our skeletal muscular system that helps to support us and allow us to move. All right, you don't have to worry about that. All right, cellular hierarchy. Remember, molecules are composed of atoms. The young man stated atoms are made up of what? Protons, neutrons, electrons. Organelles, all right, are composed of molecules, and you look at some macromolecules like the mitochondria, the nucleus. You look at the ribosomes, the smooth ER, the rough ER. All right. Then we see cells are composed of organelles. Tissues are composed of cells. Organs of tissues. A group of organs make up organ systems, and from our organ systems, we make up a living what? Organism. Right. So this would normally be a test question on the exam. All right. Sometimes I ask you to go from high to low, or from low to what? High. All right. All right. All right. When you hear the term reductionism and holism, all right. So when you look at this, the large complex system is understood by studying their what? When you look at a human being, in order to understand a living organism, don't you have to study its individual what? Parts. How does the heart work? How does the brain work? How does the reproductive system work? So you're looking at the simpler parts of it to understand the whole. All right? So holism is that I cannot predict the properties of the separate entities. So I need to look at the entire organism. So we are made up of all of our parts that what? Work together. Like a vehicle. All right? If the engine doesn't work, if the carburetor doesn't work, if you don't have gas in it, none of it will what? Work together. All right? So we are some of all of our what? Parts. All right, anatomical variations. What do you think that means? All right. That's a normal. Kidney. All right. Look at the pelvic kidney. What's wrong with the middle one? What's wrong with that diagram? Is that normal? All right, because the kidney is supposed to sit where? In your retroperitoneal cavity towards your what? Back. That doesn't sit there. They should be two separate kidneys. Is this a separate? So that's abnormal, right? All right, that's a normal heart. These are variations. All right? So sometimes people can have what? Abnormalities. You know, they have kids born with half a brain. Some kids are born with half a heart. All right? Some kids are born with no legs, no arms. Okay? So that's what they mean by anatomical what? Differences. Make sense? All right. All right, so when we look at organization, living things exhibit a high level of organization, cellular composition, matter. What's the definition for matter? Matter. All right, and has a mass. All right, is this matter? It's occupying a space. Does it weigh something? Yeah. All right. What is metabolism? Metabolism. The sum of your chemical and physical what? Activity. Is how you what? Consume things and break things what? Down. All right? So they mention what? Anabolism, to build things up. Catabolism breaks things what? Down. All right? Responsiveness, stimuli, your nervous system. All right? That means you respond to things that you need to get out of the way of, or things you need to go to. Make sense? You respond to your what? Environment. And then movement. All right? Organisms move from point A to what? Point B. And that's when you look at the what? Skeletal muscle system. Here we're going to be looking at nerves and chemicals and electrical impulses that makes those muscles and joints move. All right, question. How many people remember what homeostasis means? Homeostasis. Anybody? Homeostasis is a steady state. All right? Stability. Development is what? Growth and differentiation. That means things what? Change. Reproduction is passing on what? Genetic information to your what? Offsprings. And that's going to be a change in what? Your genetic makeup. Make sense? Okay. What happens when we have genetic defects? If you alter the genes, what happens? Yeah, mutation. All right. All right, so age, sex, diet, weight, all of these vary in between men and women. A male, 22 years old, needs about 2,800 calories per day. A female, 128 pounds, requires what? About 2,000. All right? Based on her what? Size and metabolic activity. Okay? Make sense? All right. Let's take a 5-minute break, then we'll come back and finish the rest of this lecture. We indicate homeostasis is a steady state, maintaining balance. All right. So in here they talk about two parts of homeostasis: negative feedback and positive feedback. All right. Negative feedback. That's a component that tries to maintain equilibrium. That means it has set points. All right. So everybody has a thermostat in the house, right or wrong? All right. You set it before you left the house today, right? So you set it at a temperature. What do you expect the thermostat in your house to do? Okay, and what happens if the temperature goes too high? If it goes too low? So whatever you got your temperature set at in your house, you expect it to stay within that what? So negative feedback is something that will what? Reset itself. Either by turning something on or by turning something what? Off. Make sense? All right. All right, so homeostasis, negative feedback. So when we change room temperature, the thermostat will either be activated or inactivated. Either it's going to put heat on or it's going to turn heat what? Off. But the bottom line is it wants to maintain that temperature within that range that you what? Set the thermostat on. Make sense? So when our body deviates from normal, then we get what? Sick. Normal body temperature is what? 98.7. All right? So if it goes too high, we got a what? Fever. If it goes too low, we get what? Cold, which can also sometimes be a form of what? Illness. But the key thing is, it's different than the what? Set range. All right? So we deviated from what? Homeostasis. All right? When you look at a diabetic, what tends to determine if a person is a diabetic? What's not working? What organ? Huh? No. I take that back. Diabetes can affect the kidneys, but what organ regulates your blood sugar? Start with a P. Yeah. All right. What does the pancreas produce? All right. So if the pancreas is not producing insulin, isn't that an abnormality? So it's not doing something it is what? Supposed to do. So end up having what? Diabetes. So we're not maintaining what? Okay then. Make sense? Very simple. All right. All right. I'm going to ask you something that I talked about earlier. Give me a definition for metabolism. And what are two terms that define metabolism? And? Okay. So if you break things down in order to do what? Build things up, right? What's the term that defines breaking things down? Catabolism. What's the term for building things up? Anabolism. And another name for anabolism is synthesis reaction. Okay? Make sense? All right. So what happens when you get cold? You shiver. Why do you shake? Okay then. Aren't you trying to reestablish what? Heat. What happens when you get too hot? Yeah, you do. And you sweat to do what? Okay. So we're trying to do what? Reset normalcy. That's what? Negative feedback. Make sense? All right. If I tell you positive feedback, what do you think about? Positive feedback. It enhances something. It keeps it what? Going. Okay? All right. This is another thing they give you an example. People rise up out of bed. Blood drains from the upper body, creating homeostatic what? Imbalance. You see a lot of elderly people say they have what is called positional hypertension or hypotension. Now, sometimes people stand up too fast. They get vertigo, dizziness, because you get a change in that what? Blood pressure real fast. Okay? Hey, and also when we look at baroreceptors mean what? Pressure receptors. Okay. So when you take the keys?
I said I'm going February the 8th.
Okay. Okay.
Well, I might have to push it back. Feel like that. It's a lot of reasons.
For the south side.
Oh,
Oh, okay. You take that from.
Miss French.
And you take that on Monday? What time? Are you?
No, we right there.
Oh, okay. Because I'm here on Monday. All right. Yeah. Yeah. So I thought you were going to get together. Did you get the textbook for the team? Did I give you just the book or did I give you the textbook? Did I give you two things? Okay. Well, I got another one. It's the, it has the sample textbook. About 5 or so sample textbooks. All right. Hey, Karina, what's going on? Yeah. So just check with me. You can make a copy of it. All right. All right. When we look at blood pressure, all right, and when we go to lab tonight, when you look at the heart, but you got what they call pressure receptors in your major veins and arteries in the leg. Your carotid artery. So it monitors the blood when it leaves the heart. So if the heart rate is up, it puts pressure on the veins in your neck and arteries and make them what? Bulge out. So that lets you know your what? Pressure's up. That sends a signal to your brain to tell your heart to slow down. And if the heart slows down, then that should make your blood pressure do what? Go down. And that helps to regulate your what? Blood pressure. If your blood pressure is low, then the baroreceptors pick that up. They send another signal to the heart to tell the heart to do what? Speed up. And if it speeds up, it does what? Raise the blood pressure. Is that an example of negative feedback? Yeah, because it's doing what? Resetting itself. Make sense? All right. All right, the next thing they're going to talk about let's see. Positive feedback. All right. All right. I'm going to do this example, then I'm going to go back. All right. You have two hormones that the posterior pituitary gland produces. It's called oxytocin is one and antidiuretic hormone, right? But we're going to look at oxytocin, all right? Anybody giving birth? Nobody? Okay, all right. So as you get close to cervical dilation, the appropriate centimeters, your body produces oxytocin naturally. And oxytocin is a hormone that causes smooth muscle contraction. So that's supposed to help your uterus contract to do what? Push the baby out. All right. Let me ask you this. What if your contractions are not coming like they want them to and you pretty much dilated? What do they give you medicine-wise? In the form of an injection, Pertussin, right? Which is a what? Medical derivative of oxytocin that your body what? Makes. And it does the same thing, help you push that baby out. All right. After you deliver the baby, do you still produce oxytocin? Yes or no?
I don't think so.
Nope.
I don't think so.
Okay. Let me ask you this. How many of you all breastfed? All right. So to breastfeed, you need 2 hormones. One of them comes from the posterior pituitary gland, which is oxytocin. That works with one that comes from the anterior pituitary gland, which is prolactin. All right? So why is it important and good to breastfeed? Huh? It's good nutrients for the baby, but how does it benefit you? Well, now I want to keep your breast from filling up with milk. It helps your uterus contract, because every time you breastfeed, your uterus contracts and it shrinks back to its normal size naturally. Women back in the day didn't want to breastfeed. They would get injection to draw up their what? Breast milk dried up. But they had an increase in what? Uterine cancer, because the uterus did not contract back to its normal size naturally. And your body keeps producing the oxytocin as long as you breastfeed. That's positive feedback. Have you ever been out while you was breastfeeding your baby at daycare and you sitting at a table and somebody's baby crying and your breast leak milk? I wonder why. Why do you think? The hormones from the posterior pituitary gland is regulated by nerve stimulation. And when you hear a baby cry, your maternal instincts kick in to feed that baby. It ain't yours, but your breast getting ready to feed a crying baby. Make sense? So that means you got the endocrine system and the nervous system working together to breastfeed. And that's positive feedback because it keeps running as long as you what? Breastfeeding. Make sense? All right. Yes. Yeah. They used to do, you know, old-time remedies. You know, they used to say when a woman had a baby, you couldn't get wet, you know, for so many months because it'll make you sick and ill and all that kind of stuff. All right. You haven't? Yeah. Back in the old folks' remedies. All right. All right. But that's positive feedback. All right. Let's look at receptors, integrating, and effectors. What do receptors do? Receptors. Yeah. So, do y'all feel the temperature in the room? Okay. All right. So they are receptors that alert you what's going on the outside of your body, and it sends a signal on the inside of your body so you can what? Adapt to it. What is integration? Integration. Yeah. When the information comes in, doesn't it have to go to the appropriate region of the brain so your body can respond to it? All right. Effector. What is an effector? It carries out the response. All right. So if your body is producing prolactin and oxytocin, what would be the effector cell? Your breast, because it produces the what? That's the effector cell. It responds and carries out the function of the what? Stimulus. Make sense? Okay. Question. Have I said anything that you don't understand? All right. All right. So we talked about matter and energy and a gradient. All right. So gradient means the flow of energy. All right. from high to what? Low. All right? Movement in opposite direction, either go what? Down the hill or what? Which one requires more energy, going down or going up? Right. Going down, little or no energy, right? Okay. So it's the displacement of energy, all right, from one place to another. So normally we go from what? A high concentration to a lower concentration. All right. All right. All right. Terminology we kind of mentioned. You got root or stem words. You got combining vowels. You have what are called prefixes and suffixes. All right. An acronym. All right. What letters means what? Like A in front of a word means without something. All right. Avascular means what? No blood supply to that particular what? Region of the body. All right. Plural, more than what? One. All right. Brachium, arm, brachii. All right. Biceps, brachii, nouns or adjectives, what we look at. So there's a table that kind of breaks the prefixes and the ending of words down. All right. What they mean. And they can have different terminologies. All right. So these are just some review terms. What did we say cell theory was? Cell theory. Remember? We all are what? We all evolved from a what? Common ancestral cell. Evolution being able to what? Adapt and evolve. Who remembers the hierarchy of complexity? Atoms, molecules, organelles, cells, tissues, organs, organ systems, organisms. Homeostasis, maintain a steady state. Okay. All right. Yes. They're all on Blackboard. All right, that's an X-ray. It shows what? It really doesn't show soft tissue, but it shows what? Bone. All right. All right, that's a radiopaque imaging. It shows the blood vessels from that standpoint. So they inject fluid in to look at it and how it's distributed. Okay. That's a CT scan, how they break it down and cut different splices in it to look at it. All right. All right, that's a Petrotron scan. Positron emission, all right? So they look at the gamma rays that's given off to detect what? Tumors, masses, blood clots. Okay. MRI. All right, and a sonograph. They send ultrasonic waves in. When they hit it, it rebounds back, and it gives them a what? A image. Okay? All right, that ends this part of chapter 1.